Hello, geometry students. The next 6 videos are all going to be about the magic inside a right triangle. Prepare to be amazed. The first theorem we're going to learn about with the right triangle is the Pythagorean Theorem. And this is going to be important to know some vocabulary first. If you have a right triangle, there's a right angle, and the sides coming out of the right angle are called legs, and the side across from the right angle is called the hypotenuse. This vocabulary is important for understanding the Pythagorean theorem, which states if you have a right triangle, this is always true, which is amazing. The length of one leg squared plus the length of the other leg squared is always going to equal the hypotenuse squared, which is fascinating that this happens inside a right triangle. And because that happens, if we know 2 out of 3 of the sides, we can figure out the third side. So let me start with this example. First, ask yourself which side is missing. It's the side across from the right angle, so we know we have to find the hypotenuse. And so what we're going to do is we're going to use our Pythagorean theorem, which states the leg squared plus the other leg squared is going to equal the hypotenuse squared. We'll call it x. And now we use our Algebra 1 skills to solve. We square each thing, we add them together, and now we take the square root of both sides. Now, when you take the square root, you will get a plus or minus, but we know that we're applying our math. Lengths are always positive, and so we only take the positive 29. So the length of the hypotenuse is 29. So now pause and you try, and then press play for the solution. First step, we see that the side that's missing is across from the right angle, so we know we need to find the hypotenuse. So we use our Pythagorean theorem, which states leg squared plus the other leg squared equals the hypotenuse squared. Then we solve for x. We square both of them, we add them together, and then we take the square root of both sides. It would be plus or minus 26, but because we're applying our Algebra 2 geometry, we know we're looking for length, which is always positive. Okay, now what if we're missing a leg length? So notice if we're looking at this picture, we see the side across from the right angle is known. We know the hypotenuse and we know one of the legs, but we don't know this other leg. Well, we can still use the Pythagorean theorem. It's just that we have to be careful of what we're known and what we don't know. We know one of the legs and we know the hypotenuse, but here's our missing value. This x is going to go in for one of the legs this time. And so when we set up our equation, it's x squared plus 8 squared equals 20 squared. Remember, the hypotenuse always stands alone. Now we solve for x. We square and we subtract, and then we take the square root of both sides, knowing that we only, in general, when you take the square root, it's plus or minus, but we're looking for length, so we take the positive. So now you try, pause the video, try on your own paper, and then press play for the solution. The first step is to always draw a diagram. We see that we're missing a leg. We have the hypotenuse and one of the legs, but we're missing another leg, so we use the Pythagorean theorem, and we set up the equation leg squared, the missing guy, leg squared equals hypotenuse squared. We square those guys, we subtract the 36, and then we take the square root of both sides and only keep the positive option because we're looking for length, and lengths are always positive. Now, before we snazify, you pause the video and at least practice 1 or 2 of these to make sure you've got the basics, and then press play for the solution. All right, now let's snazify a little bit. Sometimes you have to do 2 rounds of Pythagorean theorem to find what you want, because notice you can only use the Pythagorean theorem if you have a right triangle. So notice we have 2 little right triangles inside this bigger black triangle, and we want x, but right now inside this right triangle we only know a leg, but we're missing the other leg and we're missing the hypotenuse. You can only use the Pythagorean theorem if you know 2 out of 3 of those things. If you're missing more than one thing, you've got to look for another way. But how could we figure out this altitude here of this triangle? Well, we could go into the triangle on the left first, because we do know 2 out of 3 pieces there. Then once we had that information, we could hop inside the triangle on the right. So let me repeat that a little slowly. Sometimes you need to do 2 rounds of the Pythagorean theorem. So you can only use the Pythagorean theorem on right triangles. So first we're going to look at that triangle on the left, and we're going to call that altitude y, and we're going to use Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. Make sure to put a parentheses around this guy if you're using your calculator to square it. Make sure that you get 80. And then we're going to subtract 16 from both sides at square root. We get plus or minus 8, but we take the positive 8 because it's a length. Okay, then we can do our second round because now we know that the altitude's 8. So that allows us to hop inside this triangle on the right and use Pythagorean theorem to finally find x, which is what we really wanted. Now we know leg squared plus leg squared equals our missing hypotenuse. And we can solve for x. Okay, now you try. Find AB. Pause, use your own paper, practice on your own paper, and then press play for the solution. So we want AB, but right now this right triangle we know it's right because of the linear pair here. And we want AB, but right now this triangle's missing a leg and hypotenuse, so we know we can only have one thing missing to use Pythagorean theorem. So let's start over here in the triangle on the right. We know 2 out of 3, so we'll use Pythagorean theorem, we'll find the altitude, BD, then that'll allow us to hop inside the triangle on the left, we'll know 2 out of 3 things, and we can finally find AB, which is what we really want. So remember, you can only use Pythagorean theorem on the right triangles. First, we're gonna find BD in the triangle on the right. And when you do that, you find that it is 4. Then that allows us to hop inside the other triangle. Now that we know that BD is 4, we can now finally find AB. So we do another round of Pythagorean theorem. And you can leave it as a radical, but it makes a little more sense to have rounded to a decimal when we're talking about lengths. And so I will leave you with this picture of my oldest child's fur babies, Lemon, snuggling with Willow. And I wish you a great day.